The analysis of variance included three main contents. And this week, we firstly will learn how to use one-way ANOVA. Next week, we will continue to learn univariate analysis of variance, analysis of covariance. Okay? Yeah. ANOVA is very widely used in data analysis. It's a very useful way. And also, it's a way similar to Ttest. Here, yes, please pay attention to the similarity and the difference between Ttest and ANOVA. Okay? Ttest is test the hypothesis that the two samples have the same mean, while ANOVA tests the hypothesis that the three or more samples. So Ttest 2 samples, ANOVA 3 or more samples have the same mean. Okay, so here, for example, please test if the mean height of female high school students from China and Korea are the same. Here, because we have the China high school students and the Korea high school students. So here we have 2 samples, okay? In this case, we use Ttest. Okay, and if the question is, please test if the mean height of female high school students from China, Korea, and Japan are the same, then here we have 3 samples, China, Korea, Japan. 3 samples, we need to use the one-way ANOVA, not the Ttest. Okay? For example, please test if the mean bust measurements of young women aged 20 to 25, 25 to 30, 30 to 35 have no significant difference. Here we have 3 samples, age 20 to 25, age 25 to 30, age 30 to 35. Then we use one-way ANOVA. Okay? Okay, so yes, from these some examples, yes, please remember the key terms. Yes, you can identify which is the factor, which is the level, which is the dependent variable. Okay. For example 2, dependent variable is height. Factor, nationality. And the level, we have 3 levels. China, Korea, Japan. 3 levels. Okay. So factor, nationality, level, China, Korea, Japan. Example 3. This is the example 3, right? The dependent variable is bust. The factor is age. Level is 20 to 25, 25 to 30, 30 to 35. Okay, understand? Yeah, it's very important. Okay. Okay. Next, please look at the assumption under which is ANOVA is reliable. Yes. Firstly, all the samples should be independently and randomly selected from the population of interest. For example, if you want to compare the height from China, from Korea, from Japan, all these people should selected randomly. And also, each population of scores should have a normal distribution. That means the people's height from China, the people's height from Korea, the people's height from Japan, they are all normal distribution or close to normal distribution. And then the third condition is homogeneity of variance. That means the different populations of scores should have similar variance. Just like the T-test, the independent T-test, yeah, we will test the variance if they have the equal variance or not equal variance. Okay. Here is the assumption testing. Okay. Okay. Now let's look at one-way ANOVA. Okay. Now here for this week, we will use the Viagra data. Firstly, please test whether the dose of Viagra has effect on libido. Okay, here, the dose of Viagra has placebo 1. We use 1 to indicate placebo. If we use the low dose of Viagra, then the low dose is 2, indicates with 2. And if for these people we use the high dose of Viagra, then it means high dose is 3. Okay, so all of these people in the experiment, they will be divided into 3 groups. One group will use placebo. The second group will use the low dose, and the third group will use high dose of Viagra. Okay, and after 6 months, then we test their libido, test and record their libido. Okay, and then what do you want to test? Because we want to test whether the dose of Viagra has effect on libido. Okay, for this example, please tell me which is dependent variable, which is the factor, and how many levels of the factor do we have? Okay, 3 questions. Please answer it. Okay, would you please answer it? Please test whether the dose of Viagra has effect on libido. Dose of Viagra, 1 means placebo, 2 means low dose, 3 means high dose. Which is dependent variable? Which is factor? How many levels do we have in this case? Okay, would you please answer it? Yeah, 3 levels, right? Okay. Which is the dependent variable? Which is factor? Yeah. Dependent variable is dose. Is that right? Okay. Anyone, please tell me the dependent variable. Yeah, it has 3 levels, right? That's right. It has 3 levels. So that means the factor have 3 levels, right? 3 levels, right? Okay. Okay, and here my question is, which is the dependent variable? The dependent variable. Okay. Yeah, that's why I think I need to ask you. Here, look here. Okay, and then because here the dose of Viagra has effect on libido, right? Okay, so that means the libido is the dependent variable. When we use different doses of Viagra, the libido will be different. So here, the dose of Viagra is the cause. The libido is the desired. This is the cause, this is the desired. So this is just like Y. It's just like X. Y is dependent variable. The dose of Viagra is the factor. And we have 3 levels. If the dose of Viagra is placebo means no Viagra, but the patients, they don't know, then we call it a placebo. In fact, it's zero dose of Viagra, okay? And then the dose of Viagra, if it's low, then it will be indicate 2. If we use the high dose of Viagra, we use 3 to indicate, okay? And yes, we think that the different dose of Viagra has effect on libido, but we are not sure. So we conduct research on this issue. We use the experiment to test. When we use the placebo, the low dose, the high dose, 3 groups of people. After they use the different dose of Viagra, then after 6 months, we will test if their libido is different or no. In fact, the libido, the Viagra has no effect on libido. Okay, so here dependent variable is libido. the dearth of virgule is the factor. Okay, just sometimes please test whether the type of T has effect on weight loss, for example, like this. And we use type 1 T, type 2 T, type 3 T. Then here, the type of T is the factor. Okay, the weight loss is the dependent variable. Okay, good. Yes. Yeah, here is another example. The type test if the type of T have effect on weight loss. Okay, here the dependent variable is weight loss. And yeah, because we have 3 types of T, so we use 1 to indicate the type 1. One T, and one kind of T, and 2 to indicate another type of T, and then 3 we indicate the remainder type of T. Okay, so if we have 3 types of T, then the factor is type of T, and the factor level is 3. Okay, here is another example. Okay. Yeah, firstly, after we have this idea, then we continue to test. Yeah, please open the virgule, save. Yeah, here is the virgule file. Okay, here we have the participants. The participants totally, let me show you. Yeah, we have 15 person. Okay, and the second variable is dearth. Okay, but dearth means dearth of virgule, and here 1 is placebo, 2 is low dearth, and 3 is high dearth. Okay, and then here is the dependent variable libido. Libido is the scale measure, Okay, please test if the dearth of libido have effect on the dearth of virgule has effect on libido, and also here we have 3 levels. In this case, we will use analyze, compare means, one-way ANOVA. I told you we will use one-way ANOVA here, right? Yes, for Ttest we have 1, 2, 3 methods, and today since here it has 3 levels, so we can't use Ttest. We have to use the one-way ANOVA. Okay, that's why I told you it's very important for you to know which one is the dependent variable. For this time, libido is the dependent variable, right? So we input libido to dependent list, this box, okay? And factor, dearth of vigor is the factor, right? Okay. Yeah. After this, next, options. Yeah, click options. Here, please select the homogeneity of variance test here, and BF, Welch, means plot. Okay. Here's the, if you have missing value, then exclude cases analysis by analysis. Okay, so it's default. Yes, we just keep it. Okay, then continue. Okay. Here, click continue. Then here, click OK. Now, we have the output of one-way Anov here. Firstly, let's look at the test of homogeneity of variance. Yeah, compare with Ttest, independent Ttest. Independent Ttest, firstly, we also need to test if the variance between two groups has no significant difference, right? Also here, we will test the homogeneity of variance among three groups. We will test if the variance of three groups are equal. And here shows the Levy statistics is 0.092. Okay. And the corresponding p value, or we can say that the corresponding significance is 0.913, which is more than 0.05, right? So it means the homogeneity of variance is assumed, right? So that means the variance among three groups are equal, can be considered equal. Okay. Next, since it's equal, then the robust test of equality of means, yes, we will not use this result. If here is less than 0.05, then we will look at the result here. This is for the unequal variance. This is for the equal variance is assumed. This is the equal variance is not assumed, then we look at here. If the equal variance is assumed, then we look at here, okay? Okay, from here, look. The F value is 5.119. The F value is 1.559. and the corresponding significance is 0.25. So that means the observed significant value is less than 0.05. Hence, there was a significant effect of Viagra. Okay, understand? Here's the mean of the mean plots. If we use the placebo, then the mean of the libido is here. If we use low dose, it's here. And if we use high dose, then the libido is here. It's more than 5. Okay? Here's the mean libido of different doses of placebo. The placebo, the different doses. Okay. Okay. So the analysis you also here can help you to understand. Yeah. Here's the test of homogeneity of variance. Right? And the null hypothesis is the variance of groups are the same. And through the results of the test, the value of the significance is 0.913, which is more than 0.05. Hence, the variance of 3 groups are very similar or are the same. Okay. So here, through the test of homogeneity of variance, the equal variance is assumed, right? So the equal variance is assumed. Then we look at the result here. Here, the null hypothesis is Viagra has no significant effect on libido. They are the same thing. The means of libido among 3 groups are the same. Okay, you can use this null hypothesis or this hypothesis. Null hypothesis, they are the same thing. Okay. So here, the F value is 5.119, right? And the observed significant value is 0.025. Right? 0.025 less than 0.05. 0.025. Yeah, if it's 0.025, it's less than 0.05. Therefore, there was a significant effect of Viagra, right? Therefore, there was a significant effect of Viagra. Okay, so this time the equal variance assumed, so we use this result. If the test of homogeneity of variance, the significance is less than 0.05, which means the equal variance is not assumed, then please use this result. Okay? Right now we don't use this. Okay? Understand? Okay. So it's for this lecture, let's have a break. Okay? And then we will continue the further study of one-way Anov. Okay?